And welcome to another episode of Astronomy Daily. This is Steve Dunkley sitting in for Andrew Dunkley, who is away making sure that the curvature of the Earth is exactly where we left it.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.
And while Andrew's away, Halley tells me that she's been practicing her human affectations. How are you and how's it going?
I'm great, Steve. Can you tell me why the chicken crossed the road?
Oh, well, that will be to get to the other side, I think.
But was it unsatisfied on this side of the road? I don't get it, Steve.
I think maybe you need to work on that a little bit harder.
Oh dear, I'd better get on with the news.
That'd be great, Halley, thanks.
On September 30th, 2022, the U.S. Federal Communications Commission revealed a new 5-year rule for deorbiting satellites. The new rule means that satellite operators in low Earth orbit must dispose of their satellites within the 5 years following mission completion. This represents a critical step forward in the new era for orbital debris and space safety. Previously, the prior rule implemented a 25-year deadline for deorbiting satellites after a mission. The long and short-term challenges and impact of orbital debris have been well documented lately. Discarded rocket cores, defunct satellites, and other types of spacecraft debris are increasingly filling the space environment, posing safety and logistical challenges for missions in the future. The new ruling means space companies need to be more accountable. This will lower the risk of collisions, which create further debris. The impact of the new 5-year rule should not be underestimated, considering there are currently over 4,700 satellites operating in orbit and the majority of these are commercial LEO satellites. Firefly Aerospace launched its Alpha rocket for the first time last week, and while it was seen as a complete success, its satellite payloads did not reach their desired orbits and re-entered Earth's atmosphere earlier than expected. According to the Texas-based company, the 29-meter-tall Alpha rocket was supposed to launch the satellites to a target destination of 300 kilometers above Earth, but most were deployed far below. The blastoff marked a significant milestone for Firefly, as it was the first successful test launch of its Alpha rocket into space after its initial attempt was a failure in September 2021 when one of its 4 Reaver engines prematurely shut down. The demonstration mission was named FLTA-002 to the black, and the rocket carried 2 CubeSats and 5 PicoSats for multiple companies. Most of the satellites were newer versions of the ones that were lost during the first attempt last year, including payloads for NASA's demonstration satellite mission, TechEdSat 15, Teachers in Space, and Libra Space Foundation. Meanwhile, Lucy is a NASA space probe on a lengthy 12-year journey to 8 different asteroids, visiting a main belt asteroid as well as 7 Jupiter Trojans, which are asteroids that share Jupiter's orbit around the Sun, orbiting either ahead of or behind the planet. All target encounters will be flyby encounters. It's been a year since NASA launched its Lucy spacecraft on a mission to Jupiter's Trojan asteroids. On Sunday, October 16, at 7:04 a.m. Eastern Daylight Time, NASA's Lucy probe will wave hello to Earth for the first time during a brief, but potentially dangerous, rendezvous. In the unlikely event of a collision, the mission team has prepared maneuvers to protect the spacecraft from satellites and space junk. And that's all the news from me today, Steve. Steve, it would be terrible to have a collision on such a long mission, wouldn't it?
You are so right. That would be an absolute tragedy. And some of these space pioneers are going to extraordinary lengths to get their payloads into space. And we watch with bated breath to see how the next few launches are executed. Meanwhile, scientists using the ESO, the European Southern Observatory's very large telescope, have found the heaviest element ever discovered within the atmosphere of an exoplanet, and they've done it twice. The element barium, which is 2.5 times heavier than iron, was observed in the atmospheres of the ultra-hot gas giants WASP-76b and WASP-121b, 2 exoplanets, also known as planets that orbit stars outside our solar system. Both planets are known as ultra-hot Jupiters due to being similar in size to Jupiter and with surface temperatures that soar above 1,000 degrees Celsius. This is due to them being orbiting very close to their host stars, which means that a year on WASP-76b and WASP-121b takes only 1 or 2 days. This close proximity gives these planets unique features. In WASP 76b, for example, astronomers theorise that it rains liquid iron. The barium discovery has perplexed astronomers who found the element by accident. Thomas Azevedo Silva, a PhD student at the University of Porto, and the Instituto de Astrofísica de Ciências do Espaço in Portugal led the study published on Thursday in Astronomy and Astrophysics. We were not expecting or looking for barium in particular and had to cross-check that this was actually coming from the planet since it had never been seen in any exoplanet before, Mr. Azevedo Silva said. The puzzling and counterintuitive part is why there is such heavy element in the upper layers of the atmosphere of these planets. Study co-author Oliver Demangian expanded on why it was so unusual to find barium on these exoplanets. Given the high gravity of the planets, we would expect to find heavy elements like barium to quickly fall to the lower layers of the atmosphere, he explained. The question for scientists is, what natural process could cause this heavy element to be at such high altitudes in these exoplanets? At the moment, Mr. Demangian said, we are not sure what the mechanisms are. Barium is so reactive it does not occur in its pure form on Earth, but can be purified and is used in paint, glass making, and to achieve a brilliant green colour in fireworks. Scientists say that the discovery of barium on these exoplanets is just scratching the surface of what can be learnt from mysterious planets. Now, have you ever heard of the Man in the Moon? Lots of people have. I think there's a song that we used to sing at children's school. I can't remember what it is. But if you've ever looked up at the full moon and seen that face looking back at you, you're looking at the Man in the Moon. And have you ever wondered why our moon has a face? Is it just the song? Or is it just the child's stories that makes it look like, or makes us think that there is a face? Over billions of years, asteroid impact craters and the aftermath of lunar volcanic eruptions gave the moon a sort of iconic appearance. Lava from these eruptions often filled lunar craters where they were hardened into dark volcanic rock that made them stand out, and that gave the moon its facial characteristics. And that likeness has remained over the eons due to the absence of atmosphere and plate tectonics, which would have otherwise deformed or destroyed the moon's ancient geological features. Ya-Hui Huang, a planetary scientist at MIT, studies lunar craters and how the face of the moon came to be what it is now. Asteroids and fragments in the early history of the solar system were big because of planet-forming events. He said, impact craters of extraordinary size at the surface of the moon about 4.4 billion years ago have left their mark, and shortly after, a Mars-sized protoplanet named Theia collided with the young Earth, breaking off a huge glob of the planet that eventually became the moon, it is thought. It was then that the moon began to get a facelift, according to John Fairweather, a doctoral student at the School of Earth and Planetary Sciences at Curtin University, right here in Australia. During this time, the orbits of the major planets or asteroid belts and planetary rings were not yet stable, and rocks and material were being pulled and pushed in every direction around the sun. Fairweather said, the moon's then fresh surface would have been heavily bombarded and scarred to the level we see today. Unstable orbits for the early solar system's various planets and space rocks meant that gravity was flinging objects in all directions. During the chaotic period, gravitational forces from larger objects, such as the masses that would eventually become planets, flung smaller objects, such as asteroids and tiny planets, out of the way, according to a 2022 study published in the Journal of Nature Astronomy. These smaller objects bombarded the solar system's bodies, including the moon, and left their impressions behind. The moon has experienced spikes and lulls in asteroid collisions, and it was pummeled during the first 1 billion to 100 million years of its existence. This is a quote from Fairweather again. Then some 900 million years ago, impacts started to decrease gradually as objects in the solar system stabilised, with their orbits becoming less erratic. However, the moon is pockmarked with more than just craters. Volcanoes used to erupt on the moon when it was young and temperamental between about 4.1 billion years and 3 billion years ago. When lava oozed onto its massive craters, it formed a feature known as mare, the Latin word for ocean, according to BBC's Sky at Night magazine. These maria, the lunar seas, appear darker than their surroundings because globs of lava hardened into especially dark volcanic rocks such as basalt. The maria also took on rounded shapes that vaguely resemble the features of human face. In terms of the moon's face, it is the most distinguishable feature we see from Earth. The dichotomy of the dark mare and the bright highland, Huang said. The Maria formed those large basins flooded by episodes of volcanic eruptions. The remains of these epic collisions, such as the South Pole Aitken Basin, the oldest impact crater with a diameter of 1,550 miles or 2,500 kilometres, are still visible on the moon today and look like a multitude of lunar eyes from afar. Huang thinks the Imbrium Basin, the second largest basin on the moon, is part of its face. And I just love stories about the moon. I think it's because it's the big bright thing that I see every night. It's a very friendly celestial body. And that wraps up another episode of Astronomy Daily. Thanks for joining me today. And don't forget, you can catch all the episodes of Space Nuts with Andrew Dunkley and Professor Fred Watson on this address, spacenuts.io. Head over there, and if you'd like to catch all the episodes of Space Nuts and Astronomy Daily, click on the appropriate links and you'll get everything you want for your daily dose and your weekly dose of astronomy, space and stuff. It would be great for you to join us. And did you sort out that chicken problem, Halley?
I'm just concerned that you humans just let chickens cross roads unattended. It seems careless.
Maybe Hal and Siri can help you with that one.
Okay.
This is Steve Dunkley sitting in for Big Brother Andrew Dunkley, and we'll catch you on the next Astronomy Daily.
See you next time, Steve.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.